So welcome guys. This is the question edit distance. This is the edit distance question. So what this question says that we are given two words, word one and word two, and return the minimum number of operations required to convert word one to word two. So what are the operations we have? Insert a character, delete a character, and replace a character. So suppose we are giving these two characters. Okay, so what we are doing here, we are checking the which character we are checking with the agent or we are checking with the first character. Is it same? No, it is not same. So what we can do, we can choose any of these operations, insert, delete, or replace. Okay. So which operation we did that? We choose replace. Okay. After that, H and R will be same. Then O and O these are same. Not do anything. Then R is R and S. What to do with R and S? We can replace, we can add something here, or we can not do anything. And also we can see that the range of this problem is 500. 0 word length 2 is 500, and word 1 and word 2 are consist of lower case English letters. So what we have to do is this question is as we can see here in the related topics also. This is a problem. This is a problem of string and dynamic programming. So, so what we can do here? Let's see. This is the problem. So horse. We have three operations: insert, delete, and characters. So definitely it is a DP problem. Let's try to solve it. So they solve this question using because it's why where I say writing a function in Java. In distance it can work also. So public int distance that can be same also. Then we are passing a string. I will write S1 and I will write S2. This two will be strings, and what we do is we will pass the length with zero indexing. So int n is will be length and int m will be length. Now let's do it from here, then we will try out what is the situation here. So int n is equal to word 1 dot length, word 1 dot length, and what will be the size of m. So let's make it is make space optimized. So m will be what 2 dot length. So we have the two lengths. Now we need to call this function. So what this function will call? Okay, suppose if this function returns anything, return main distance. So what we will pass? We will pass word one, then we will pass two, then we will pass what n and m, or we will pass n minus one or m minus one. We will pass n minus one or m minus one. Okay. So these are the things. So still now, what we do? Let's take one example also. Let's take this example of horse and suppose this is a horse and different word is road. So okay, ROS. Let's take it from this way. Okay, we will be comparing from. Let's compare it from. We can compare from this side also, initial point, or we can compare from last side also. That is E and S. So generally in your mind, what we can say means in this problem, what we can say is we can replace also means we can replace E with S also, and we can replace okay, wait. So in this problem, what we can do is we can replace E with S also, or we can add S here also, or we can delete E also, because these are the conditions. Okay. So there is so much of variations will happen here. Why this will happen? If you do this with many test cases, you will understand that. So now, okay. So what we have to do? We have to virtually compare if A and S are equal or not. Suppose directly I will take a if condition that if S1 dot caret I n at n equal to S2 dot caret m, means if n and m are equal. So what you will do? Suppose if this and this are equal. Suppose this is not the test case. Suppose RAT. Suppose CAT. Suppose this is the test case. T and T both are equal. So what you will do? You will check this these ones. So I will directly call the function. And here, will you have anything? Will you take any cost? No. Then you will just take it for having better idea that we are not taking adding any cost here. So we are doing just 0 plus. Then what we are doing here? So we will directly call this main distance function, and we will pass what string 1 and string 2. Here one point to be noted out is we are not cutting or doing any operation on string 1 and string 2. We are just supposing that we are just virtually means getting an idea that we are just comparing only, and we are not doing any operations on string 1 and string 2, but we will just adding the cost, and we will visualize that if we add here something, if we add here L, then okay, we are adding L here, but we are not changing the string, we are only supposing. So if I insert L here, so we were comparing this one and this one. Now we will compare this one and this one. If we add this, so the index will be what? That is the thing. Which is not an easy question. So now, suppose if this was the thing, if t and t are equal, we are not doing our operation. We are just returning 0 and plus a plus. Now what we have to do? We have to do three operations. What are the rules? Those operations are what? Those operations are either insertion. What are the three operations? Operations you can say insertion, INESERTION, insertion, or we can say insertion, then deletion, and then replace. So let's think about this. What will happen if we insert the and we have to return what minimum or maximum? Minimum. So what you can do is in else part, you will just int p, and in p what you will do. Suppose now these are both are not equal. Suppose this is car car. Okay. So this and this to make this equal, there are three operations. Either you will at that index if you add, so there r will be added. So if you add r, what we are doing? We are doing insertion. So what is the cost of insertion? 1. Okay. So now, so if you are doing this, so now we have to call min distance this dis da and mean distance and I mean distance string 1 and string 2 and then and m. So we are calling n and m. Is it right? If we add something here, so this will be equal. So this is n. Previously it was suppose it is at n. Now n is what? Already it is inserted at n plus 1 positions. Now if I this is now equal to this, so what we should do? We should do if this was previously it was having m size, it was having n size. So we inserted at n plus 1 index. Okay. So now we have to check here. So it is inserted at n plus 1 index and it is now equal. R is equal. So we will go to T. So we inserted at n plus 1 position and we checked from n plus 1 position to R. Now we have to go to check T and C. So what insertion what is happening? N will remain same and M will change. Likewise, Q. Q is equal to. Now we try to do a deletion operation of mean distance S1, S2, and now you will tell me what to do. Suppose this thing is done. R and R, this R and R are equal now. So 0, 1, 2, 3. This is the index what? 3. 3 till 3 we have checked. Okay, not like this. Suppose this and this. Now distance is now suppose just suppose this size will suppose T and A. T and A. T index is 3, A index is n. Suppose, okay, n and n. Now we have to, when we are call this function, we will go there. So T and A. What is the index of T? N. What is the index of A? N. T at A. If we do one operation, if we delete it here, so to what index we will check? If we delete T, so if we delete, previously this was the index. Index is coming from what? Left side. So if we delete T, what is the index here? 0, 1, 2. 0, 1, 2 was there. So if you delete what we will do only n minus 1 will happen. If we delete T, if we delete T was at 2 index, and now we deleted. So now we will compare this and this only. So which index we will compare next? The next call we will which index to one index. So we will change 1 and here will be changes. There will be no change in string 2. That's why it is 1. Now comes the main thing. This is the insertion. This is the deletion. Okay. Now we have to do what? Replacement. Now we have to do replacement. So those two are same. Suppose this index is in this in R index is in C index is n. So if we replace R with C, what will happen? Let's see. First I will write PQR is equal to 1 plus mean distance S1 S2 and suppose it will be there will be changes here. Let's see what will happen. And this code is for replacement. So if we replace this and if we replace this, so both will be having what? If we replace R and if we replace C, so if I replace R with C, so what I will do? There will be changes in both n minus 1 and m minus 1. So this is the function. But suppose we are making these three calls. But the question is saying we have to return the minimum number of operations. So what you will do, from here you will return math dot max of P and math dot max of Q and R. At a time we can only compare two values, so this will give the minimum, and from minimum, suppose it gives S, so then again it will, oh my god, where it will be mean, it will be min. So this is the returning part. So from here we will return, and from here we will return. These two functions are going to return. Here we are not using DP till now. I will use, let's see what happens. Let's uh, make it concise. So talking about base case, you see that when we replace R and C, it came to minus 1 or something like that. So what happen is if the index goes out of bound, so what should be the value? It should be 0 or minus 1. If n is equal to minus 1 or n equal to minus 1. So what you should do? You should do any operations or no? Think you should do any operations or not? Yeah. Suppose R. Suppose you made after replacement you made C, but there was a like this two like two what this is two characters are left. So after this operation, when it gets to base case, either of them will reach to minus one. So it will reach to minus one because 0, 1, 2, it will reach minus one, and it will be having from here. It will reach to here. So 0, 1. Index is what? 0 and 1. So how many characters are left here? Index will be 1. But we will include what? Double A, to both we will include. So their insertion will take place. So how many characters we will insert? Two characters. So the cost of 2 means 2 will be added. So J will be 1. So cost will be what? J. If J, if what will happen? So if I equal to minus 1 and j is equal to minus 1, if both are equal, then directly what you will do? Um, If both are equal, you will return directly 0. If n equal to minus 1 and n is less than, oh no, no, if both is equal, either both will be equal or either it will not be equal. If n equal to minus 1, means both are minus 1, both goes down. That is car and car. Suppose if both happens, we will just return 0. If n equal to minus 1, it will be a minus 1 and there will be one character, two characters here. So what we will do? We will do what? M. M will be here, so m plus 1. So we will return m plus 1. Now what we will do? Suppose this is not still finished. Suppose here double P is there. So what will be the scenario? So what we have to do? We will insert. If n equal to minus 1, so what we will do? Return n plus 1. We will insert two elements. I'm so sorry. Here we will insert two elements. Here we will delete two elements. Okay. So these three edge cases will be there. Return. So will it work? Seriously, it will work or not? If else, I think we don't have to return anything from here. We can. So I think you will understand from this code. So let's start one. So this code is giving what are strings. Okay, so string is having parenthesis is needed for that. So now let's see. Oh my God. So this is running. This is running for what? This is for recursion part. It's working. So now what we have to do? Just check. It will definitely give daily because we have not used the DP array. So talking about DP array, how you can implement using DP. So we should think that what one is given, what two is given. So okay. One day DP will be used, TTP will be used, what will be used. So we can see that N and M. How many parameters, how many states are changing? Two states are changing. Simply conclude into your mind that matrix of 2D will be used. So this will be integer array. This will be TP is equal to new int what? The size will be what? This will be n plus 1 or m. Think it should be n and m. Why? Because what? It should be just like that because the indexes we are storing with output we directly return from here. Okay, we will pass, but we have to initialize not declare also DP array. So where we are passing DP, just copy paste. Okay, oh my God, wait, DP, DP, and DP. These three DPs are added here. Now, in DP, what we do? We will pass the DP array. Then, if the value already exists, what it will do? It will directly return. So, this is for test case. Means we can we include the return statement here? No, because in management will also come. So we have to return here. So DP, can it be the initial values of the DP array will be 0. So we should make it -1 or not? Think, think. I think yes, it made -1. Okay, for integer array, PQ, DP pass array was fill. In which array I will fill what you will fill -1. So if dp of n and m not equal to -1, okay, means the value is pre-calculated. So what you will return? You will simply return what? The value. So it is a checking part. If the value is previously calculated or not. Else, what you will do, there is two things. This is we will just add this here. If not return here, we will just add. You understand this zero, I think. I can do this also. This DP, you know that this one will have. So at last we will return what? What we will return? DP. So we will return DP of n or not. We are going from this side. This is the matrix form. So 0, 0, 1 at last. And then you go. In this matrix, it will start from this index n cross m index. It will call some these items. It will go like this from top. No, it from bottom right. From bottom right, it will start the recursion till it goes to the top left. The answer will be stored here because this is top down. So top will be here, down will be here. This is why it works. So I will use this test case. See what happens. Oh my God. line number 7 forward to pass here. This is working fine. So let's see. Oh my god. So this worked, and it beats 97.5% of the users. Just 5 years ago, it is the first time I read this code. Okay. So what about the time complexity and space complexity? So for the time complexity, what we are doing? We are creating a DP. So this DP of part size n cross m, and what we are doing? We are filling the matrix one by one only. We are not calculating for the already filled. That means n cross m will be time complexity. So you will think that this recursion is also taking some time. That is only the calling is there. So the space complexity will be what? That is space means n cross m will be also there. This is the space. And this recursion will be also having some space. That is n cross m plus that size of recursion. Size of recursion can be what? At max, it can be the max of rows and column, max of n or m. Okay. So this is